Yeah, I think we should just start.
So she's also doing that.
Yeah, she was doing a PhD with
That's it. And also,
okay.
he's a special case. He has principal purpose. So I was thinking from the science purpose. Very happy. Where is my paper?
Yes, yes. I feel it.
Okay. So again, thank you for your patience, and we are going to have another speaker, Dr. Mohammad Adil. So he is coming from Pakistan. He is a professor at UT, University of Engineering and Technology, Peshawar, Pakistan. So he'll be talking about, as you can see from his title, that building information modeling use. So I read a short biography of him. Dr. Adil did his BSc in Civil Engineering in 2003 and MSc in Structural Engineering in 2006 from the Department of Civil Engineering, UT Peshawar, Pakistan. He did his PhD in reinforced concrete sandwich panels from University of Southampton, UK in 2010. He further completed his postdoctoral studies from Kingston University in London, UK in 2011. Since then, he has joined Department of Civil Engineering, UT Peshawar. He is the Director of Sustainable Housing Research Center at UT Peshawar. He received national and international awards from Higher Education Commission of Pakistan, UT Peshawar, ISTRUC-E UK, and ECOSF, and many others. He developed undergraduate coursework for BIM for civil engineering students at UT. He has interest in multidisciplinary applications in engineering and has collaborated with many researchers across the world. Okay, without further ado, Dr. Adil.
Thank you, Shaya. Thank you, Saqib and Sharif as well for being so hospitable. Also, thanks to the Green Construction Research and Training Center of BS2 British Columbia, Okanagan, and also thank you to the Canadian Society for Civil Engineering for sponsoring this talk. Building information modeling (BIM) is a very vast thing now. As we are speaking now, it has become very fast. Like it's swelling like a balloon. And once we connect it to civil engineering, so it's actually building information modeling is to build anything actually. But then when we talk about civil engineering subjects, then it becomes more specific. And then if we compare it with the ground realities, then we realize that the situation needs some control from us. So my today's talk will be mostly the awareness and information about what actually this thing is and why it is needed. And once we, I'll try to fit civil engineers in their roles in BIM. Once I'll be doing that, we will see eventually we'll come to some construction project. But then actually what I've observed, and then other researchers are feeling as well, is that eventually what we'll gain with that will be a sustainable construction project, which will survive for a real long time, for coming generations as well. So in order to understand that, we need to know what actually BIM is. And in today's talk, as I've been told, take not much time, but so in 14 slides, I will try to revise with you that what actually BIM is. So now I really want to know that any one of you who might have heard BIM first time or maybe just heard of it but don't know what actually it is. So okay, we have fine. Okay, you as well. So I'll remain basic because I know we need to understand it's more important at this stage. So I'll try to be as basic to clear the concept of BIM first. Once we understand BIM, as I said, it's a very vast thing, but then I'll try to give a good grasp on that in those 14 slides. Once we have that grasp on it, then I will try to fit civil engineering. So it will be environmental engineering, structural engineering, and so many other branches of civil engineering being fitting inside BIM implementation, in the process of BIM implementation. And then in 7 slides, I have to tell you some important terms in BIM because it is now a standard. So once we follow a standard, we need to know and follow certain terms. So we need to clear ourselves with that. It's a huge list of terms, but I'll cherry pick some important ones out from there, and then we'll talk about them lightly. And then at the end, whatever we have learned from all these 3 stages, in 2 slides, I'll quickly sum up with how it actually relates to sustainability. And you already have gained that feeling already up till when we reach the last 2 slides. Let me start by visiting a cave. This is 14,000 BC drawing being done inside a cave art. And you will notice that this is not a very common cave art you have seen in documentaries or something. They always show some human figures and animals and they're hunting and things like that in the cave art. But these are literally some geometric things. And statistically, the drawing work done inside the caves, if you compare them with the human figures and these all hunting and stuff, these figures are 2 times more than being drawn in the caves compared to that. Still, people are struggling, the anthropologists are struggling to know what do actually they mean. But they come to a conclusion that they have certain information about building something or doing something, even if it is a hunting ground or strategy, whatever it is, there is some kind of information of building something. So this is a vision of BIM, but then we can now see where the history of BIM goes, how far it goes. It is just not random sketch they have done. Literally, they have found similar figures in kilometers distance relating to each other. So they have actually came to a conclusion they actually mean something, but they haven't deciphered them yet. Once we have been to that cave, so let's see how it has progressed to today's BIM as building information modeling, we say. So we see in 10,000 BC, like from the papyrus work being done by Egyptians on those papers and inside the pyramids, and up till as we come to the Leonardo da Vinci's time, paper artwork has been used to store information. So once I use the name of Leonardo da Vinci, I think everyone is clear what I'm talking about. The information of building something was right there in the form of art. Not a huge amount of information, quite enough to do something, to build something. Then we see drawing boards became very common in 18th century. So people sitting in big halls with so many people sitting and manually drawing with some specialized instruments, doing accurate drawings. So if you go online and search for how the Golden Gate Bridge drawings have been drawn, or for World Trade Center drawings have been drawn, you'll see figures of people sitting and then drawing boards and then slide rules, so many instruments. It's very intensive and hard work they were doing there for providing better information in those drawings. So again, what I'm saying is, what is BIM? To build something, we have to show information in a better way. And in the mid 20th century, with the advent of computer, we had computer-aided drafting then. So we had more accurate drawings, means less human error, because some of that is automated by computer now. So relatively better drawings. being done, but then again, they were just drawings. The information that we can put on the drawings, just these things were there. But then now, what we see that these drawings are not connected together. So what happens is the contractor receives a set of construction detailing drawings, and they don't know why a structure engineer has done that. They have to construct it, that's it. They don't know, they have no connect with them. The structure engineer, they receive a set of architectural drawings from an architect, and they don't know why this slab has to have this many holes in it. They just have to make it safe and economical. They have to just design it, but they have no connect with architect. And architect don't know why the owner wants this 100-story building on a small plot while he has a big area available. Why they don't want to use that area? They just don't know. They just say this is what is asked, and this is the architecture we can create. So there are all these set of drawings, but they are not connected. So with the advancement of not computer, but information technology, mobile phones, smartphones, and we have tablets, and then we know 3G and 4G internet, and now we have 5G internet as well, which is 300 times faster than the 4G we had just a few years ago. So with this advancement of information technology, now this information can be connected very, very well together. So once the architect has drawn, or once an owner has conceptualized something, they at the same time, the architect will know that what he's thinking and what or she's thinking and what's their plan. And then once architect will be drawing something, the engineer instantly will know that this is happening and this has been changed. So, and they can ask, they can collaborate, they can communicate. They have internet, tablets, and some specialized similar technologies with which they can really help each other. That don't do that because of this. So now the owner will have feedback of an architect, a structural engineer, or a mechanical, electrical, plumbing engineer, and even from the contractor and so many other stakeholders as well. As I use the word of stakeholders, let me go to the next slide to see what are these stakeholders. Now, you might have seen very commonly a term AECO, or AC is commonly used for architects, engineers, and constructors or contractors. This is a very common group that I've starred all these people here. They are considered to be the stakeholders of construction industry. But then actually what BIM has done, or well, other stakeholders that may be affected, first of all, let's see them as well, who other people are there. So there is also a detailer, a person who may not be an engineer, but then will have some diploma in engineering, something like a technologist perhaps. A structural engineer will guide them to draw the detailed drawings of steel or maybe reinforcement or steel section or connection perhaps. So they need to be connected with them, but it can be a scenario like this, that they have received a design report or design detail from a structural engineer, and they have to just simply draw the sketch of reinforcement or connections, bolting or something like that. Mechanical engineers, they're involved in the construction of a building project, in electrical, mechanical, the HVAC systems, heating ventilation systems, and other plumbings for the building, the MEP plan. So they are also involved, and sometimes they clash with the structural engineer. So structural engineer will have a beam here, and then there will be a pipe passing through that, which is practically not possible. So this kind of confusion, if it occurs at the construction time, it will cause delays and so many problems. But if these two people are connected, they will know there is a clash and they will resolve it even before going to the site or even before purchasing the all this material for this construction. We have fabricators, like for example, we have that door in this room. Someone has to fabricate that for this building in their factory. But they are never connected with these AECOs. So they at the quite end of the construction, they say, okay, now we have the structure ready, let's start finishing work. So they will start looking for different types of doors and stuff. So these fabricators, not only for doors and windows, but so many other things that need to be fabricated for a building, they again disconnected, literally not in the list in that form, but they are big stakeholders of this building. And now once we talk about energy saving and all these things in the building, then we have solar panels and then different types of them, different types of supports for them, so many connected things with them, wiring, their resistances, impedances, so many things. They need to be fabricated. And well, we'll talk about BIM once we'll talk about connection there. The site managers, this contractor is going to take the contract, he's going to do some legal talk with these owner and other legal advisors, and once everything is set, they will mobilize their equipment to the site. They may not have everything to construct that building, so they will hire they'll sublet these to other contractors, or maybe other people are required. So they start hiring some temporary staff like these site managers, which will never be contacted at the stage of conceiving of the project idea, or once at the very early stage. It seems that they're not required to be sitting in this meeting once they're talking about a building, but we'll now realize that how important these people are there, and how is it really possible to have a site manager who is going to start engaging in the construction after 6 months from today, because we're going to design and all those things. We have to draw, make drawings and detailing work. So they are going to come very late after the construction. What is their need now once we are talking about a building? Maybe there is a feedback that they can give at this stage that can save something at that site at that time, perhaps. We'll talk about it after a while. We have a separate set of erectors who will be erecting the scaffolding and perhaps the whole steel structure as well. So they are separate from the contractor. They will be hired separately. Then once the building is being constructed, we have facility manager. For example, they construct a hotel or a hospital. So there will be a management team who will be taking care of that. What BIM has done is, BIM has brought all of them together on a single table now. So from the very start, once the owner is sitting and thinking that I should construct a hospital here perhaps of this many beds, at the same time, all these people who may be engaging after maybe 2 years of construction, they will get engaged and they will talk about how a hospital facility needs to be managed, especially here when there's this many public and this type of diseases in the surroundings. So they will start bringing the social and any relevant feedback about management of the facility right on the first day. BIM has made it possible. What's missing here is the other operators of this facility. Again, for that hospital, we have a facility manager who manages the hospital, but then there are patients there. There are doctors there, nurses there. They will be the major effectees of what we have done, what we have constructed. If there's something wrong, they're going to get affected. If we have done good, they can work better. So they should also have some kind of feedback here. And yes, BIM has recently included these people to get engaged in the construction of such projects as well, mainly in United Kingdom. Well, stay with me and let me divert the discussion to another issue, and then we'll join all these things together in a single thing. Now, construction industry specifically. So now I was first of all talking about generally about building something, and then we went to the specific building industry, and now in the construction industry. On the right side here, this is a statistical graph for the production of labor productivity in construction industry in United States. Since 1964 till 2000, comparing 2004 from 1964 there, the productivity of construction industry labor is actually reducing in America. While other non-farming productivity, because farm production, the labor that is required in farming, it actually is replaced by machinery now. So it's very advanced in that form. So that's been excluded from this chart. Only non-farm labor, which is every other thing except construction industry, is shown here. They have gone very well. They have literally doubled in production. But then construction industry was dropping. On the left side there, this is the similar graph in the dotted part is specifically. This is the labor productivity in Canada. Of course, like this we can draw for so many other countries. Let's stick to these two countries only. So that is compared with USA. So if we just overlap this graph on this side here, we'll see that actually Canada was doing good earlier, but it's not a very good fit. But then it says it is less than America, so I just dropped it less than America here. But anyways, it is dropping. It's not getting better actually. So there is a need of seeing this problem that why labor productivity in construction industry is so poor, and it should be brought up as well. Again, this relates to the sustainability of that project too. And well, we'll talk about that after a while as well. Again, another jump I'm taking because it is the right time to talk about building smart. Now, BIM, as we know now, is regulated all over the world by this company, by this organization, Building Smart. So even in Canada, we have Building Smart Canada, and then also in British Columbia, we have Building Smart British Columbia. So it's everywhere in the world. They are standardizing BIM, so much so that they played the role of converting the British standards for BIM into ISO standards, which were just released in November 18 now. So now there is an ISO standard there for BIM implementation. And of course, if we can make our own techniques of implementation of BIM in any project, but then we cannot measure it, is it done good or bad? So we have to follow some standard, and luckily now, since November 18, we have a standard, so we can now learn that and implement, and we can judge how good we are going. We can actually certify our BIM processes that we do in our offices with those standards. They provided this graph that charts the effort required to be done in a construction industry, and as we go progressing from the conceiving of the idea, then designing it as by structural engineers or maybe energy specialists or environmental engineers who do the designing work of hydrology and so many other things of the surrounding feasibility reports, then design detailing, and then once design has been detailed properly, then the construction detailing so that the contractor can take those drawings and start construction. And once construction is done, then the facility management will start. Someone will take over and then keep managing that facility. This chart shows that before BIM or without BIM, the construction document production needs a lot of effort, less effort in early stages, and then blind following of those construction drawings by contractor. Whatever is drawn there, they'll just blindly follow it, and then they may do something. If there is something wrong there, they will do it wrong. They're not bothered about going back there and correct it. And once that is done wrong, then we have some circumstances for that. And then what happens is these two blue and green line, they're showing you how the control on the cost of this project is reducing as we are reaching to this stage. So we cannot, not everything has been purchased, they're mobilized to the site, we cannot do anything about it. We already have paid the money, and we have to pay all the rents of the equipment at the site and all those things. And now if there is any change that occurs, how much it will cost to correct that change or implement that change. In early stages of designing, we can do it very easily and very cheaply. But then at this stage, once there is a change that in the design, then it will be very expensive to deal with. This is in a typical project. But if we implement BIM, now this is important to know what actually BIM do. In any project, BIM actually let at the design stage all the stakeholders to connect and sit together. Sit together doesn't mean to sit like this in a meeting. The contractor will be in their own office, the engineer will be somewhere else, but using this information technology and then the communication tools, they will be well connected. What are these tools? We'll talk about them after a while. But then they will be well connected, so they will be able to collaborate and contribute in anything they see, and then they can correct all those problems that can arise later on, the contractor will be still knowing that there's a problem there. So let's correct it at that stage. So much so, this construction process will be simulated inside the computer. All a complete simulation of construction is done at that stage. So before we construct, we actually constructed inside a computer, and all the construction has been seen, how it will work. And once that is satisfied, we know there is a clash of the beam with that pipe at that stage, and we'll correct it at that time, and we'll get rid of these such design change costs that can arise in the future there. And of course, once the construction is done, that is needed to be verified by the consultant, and that will have then some legislative issues and will arise that will require the release of payment for the contractor and all these things, and court and then arbitration, all these things. They will also reduce because all of these have been already dealt with there. So much so these payments are done automatically by computers. So there is no actually issue about payments for these contractors when we are involving BIM here. So what BIM has done is it has actually moved the effort from there to there with some extra cost, because BIM experts are not everywhere. This time we need to hire some more people who are BIM experts to manage a BIM project. So there's an extra team required there. They'll ask some money. There's some software and hardware involved. They have to purchase that. So again, that cost will be there, but this is actually about the effort required. So there are some extra employment and new opportunity for engineers to learn or get certified by as a BIM expert and then get these jobs there, which will do a lot of savings. We haven't seen any savings yet. So I'll talk about savings in the next slide. So now, still this is the same chart as we were seeing earlier. The same chart in the previous slide I was showing, I just drawn it small there, matching with the current chart here. But this time on y-axis, we don't have effort now, we have cost now. So what's happening is, we can see that in a typical project without BIM, the cost of the project is increasing, and at the time of development of the construction documents, we have a peak there. Office is very busy and we are paying quite a lot for that, and then at the time they already have a fixed cost already decided for a contractor. So procurement of the material and then execution of the construction project has a fixed known amount, and then that's a drop. And then once that construction is done, this is what we haven't seen in the previous slide. Now the design life of the building will start. That may be 100 years or more, or maybe 50 or 60 years or whatever. So it is, let's assume that if it is managed by a proper facility manager, then every year there's a certain cost of management. But as the material will deteriorate, if you're not using sustainable materials, then of course we need to start paying more for similar type of maintenance. But because the material is much poorer condition, we need to spend more money. There will be a stage that we cannot afford maintenance anymore. So we either have to decommission the project, we have to repurpose the project, or maybe demolish this project, which has its own cost as well, and it needs some time as well. Now, at that stage, the green portion in the chart where we have involved BIM, what BIM has done is, BIM has simulated all this 103 years on that first day. They sat in the office and they have seen the simulation of everything happening. The management, even the management of the facility and deterioration of the materials, all of that has been simulated right at the early stage, when even there is no concept of the that what type of material or what should we purchase, from where we'll purchase all the what equipment and what plant will be brought at the site. And far before that, everything has been virtually purchased and simulated, and we know that these are the problems and they have been resolved. So if we forget about management, facility management, so after construction, everything is done normally. but then we don't bother about managing that facility. We have very less cost on management then. But then what will happen is that the material deterioration will become so heavy that we eventually have to start spending some money on maintenance. But this time, this will have huge costs on us and we'll lose a lot of money, so much so that even the decommissioning or demolition cost of such hazard which has been created will be very high as well. And if we bring BIM here, like this blue line now, what we have done is in the early stage, we have literally simulated everything, and we knew that actually the cost of facility management is increasing with the passage of time. We have seen it in the simulation quite in early stage. So we managed it, we controlled it by replacing some materials with some sustainable materials, or having not using such material that deteriorates too much perhaps. And in that way, we had a very smooth, very low maintenance cost in that time. So in terms of money, it seems that in the black area, that is the money BIM has saved for us, but actually that is the same money which has been moved on the early part there in purchasing of BIM software, hardware, and hiring BIM experts there. What BIM has done and in terms of actual saving is this thing, which is if BIM or if maintenance is not done properly, BIM concept is not being implemented properly, then this we have to spend. But then if BIM is there, this is the actual saving. Now BIM itself is about a 30-35 years old concept. And if the oldest building that has been built on BIM, which actually is not 35 years old, it's very recently been built, but imagine if it has been built 35 years old, then the only BIM building that we'll see now at this time will be only 35 years old here. So those buildings haven't seen these savings yet. We need to see them after 100 years. But we already have simulated that construction right in the early stage there. We have seen that already virtually. We've simulated all these 100 years. So we know definitely this is going to be the saving in the maintenance that BIM is going to bring for us. Now, we are now going to see gradually what actually BIM looks like. So in terms of civil engineering projects, BIM can be used for projects for construction of hospitals, offices, resorts, retail, residential, or even the whole infrastructure of a city perhaps. What will be there is BIM will have a consortium or collaboration of detailed design, which is connected with the structure analysis. So the person who is doing the analysis, they know what is that, and they will know that what is the analysis result and what are its effects. Then if now the building has not been built yet, this is just at the early stage, we are just simulating everything. So this is all simulation. Human analysis that how this facility will be used by these, perhaps it's a hospital, then how the patients will be moving, and then all those doctors and everything is managed in that way. The group of people, how they will get managed. So we can do that simulation with certain software. We can do solar analysis, other type of acoustic analysis of those buildings. Then before constructing, before even transporting the material to the site, we can actually the clash detection, as I gave you an example earlier, that about the beam and the pipe facility. So already simulated that the structure analysis wanted us to have a beam, a deeper beam there, which it may get clashed with an HVAC duct. So, but then we have figured out already here, and we have resolved it either from structural point of view or from HVAC point of view. We also have logistics simulation already, that how these cranes and this labor, a limited number of labor that we are hiring and paying money, and other equipment, other material, where we are going to place it, how much of that is required, how much time a crane will require to lift it up, move it there, and drop it there. All that will be simulated in like a computer game, far before we actually purchase or hire this equipment. And maybe we don't need 2 cranes, only one is enough. We will know it only by simulation. Otherwise, we might have purchased or hired 2 cranes, and then that could have costed a lot in that project. Then we can also do the 4D simulation of this, which means after 3D model, we bring that 3D model back to the ground, and then we start simulation of actual construction. So it's not possible to have a 5th floor before the construction of 1st, 2nd, and 3rd floor and 4th floor. So it will step by step excavate the ground. It will see how much time it will require. It will construct all these concrete columns, and then it will cure that. It will take 28 days or so, and if scaffolding is required, all that will be simulated with all details as it will be actually done at the site for in future. It's already been planned. Maybe we don't need that much scaffolding perhaps, or maybe health and safety requires this extra measure perhaps. So as per standard, that can all be observed and simulated here, and computer software algorithms are smart enough to actually advise us on that, do this or do that in this particular situation, like in clash detection. We can also, because of the like we know HoloGlass from Microsoft or Google Lens, with all these devices we can now see virtual reality or augmented reality and mixed reality. So now a contractor is or a site supervisor is standing at the site, and they want to check, is the level of this beam being poured or the beam after these shores, is it correct or not? With this HoloLens being wearing that, they will see a virtual image of the building of this beam on that level, and through that they will also see the actual construction being done and level 1, and they will see that there is a level or a slope angle error there. This is so accurate that without the total station or surveying instrument at the site, they will just see it like that. They will say, no, lift it a little bit up there. They don't need that accurate measurement anymore. They will see millimeters of lifting up through their Google Lens or in HoloLens. This is happening nowadays. So they will see it and say, okay, that's enough. So they don't need a total station with that leveling of that center bubble and all. They don't need that anymore with this all advanced equipment. And on site with augmented reality, they will do a perfect construction and on time discovery of a problem in construction, in tolerance and all these things. Once this is the construction already started, but we have to purchase all this material and everything. What BIM has given us now, it connects, like in UK it's happening, it connects once this model is done, it connects with the approved suppliers of the material, and it selects with the best of them, and it procures these material from them as well, because they are the cheapest and the best and approved. Not anyone just can make an XY cement and then mix with something and then provide it to the site, or an old bag or a 1 year old cement bag is transported. No, nothing like that anymore. There are regulated people. Not everyone can now jump in the market. We have a quality product now coming to the site, and automatic procurement. You can control that, but you can let it be automatic too, and it will be confirmed, assured, and approved, and certified, everything. So once that procurement is to be done, we need actually quantities. How much cement and everything is required to be purchased? That already been done, the quantity takeoff here, and because we already had that information available from there. Once the construction is already done, all that data is provided to the facility manager, like through a mobile phone or in a smartphone. And it will, after 5 months, it will pop up that the HVAC duct filter needs replacement or cleaning. So they will go and they will do it. They don't need to wait for a shutdown for 5 hours or 5 days of HVAC and to figure out what is the problem actually. The management system automatically will work and help the facility managers. Beside that, if imagine there's a plaza, shopping plazas to be constructed, and the owner want to do marketing of their shops, that people should start investing money in that. So they need to do some marketing too. So while we are doing that, the 3D models will serve as marketing tool right before conceiving the finalization of the project too. They can start marketing it on spot as well. And BIM has actually connected all these together, so which means that if you do a small change here, it will automatically do that change here as well. There's no need to tell someone that Mr. Facility Manager, the structure designer wants that. They will know it without knowing. They will have the correct updated information with them automatically. There are so many definitions of BIM. So mainly it is the use of computer and these IT equipments to simulate the construction before it happens by taking care of all the stakeholders at the same time. This is roughly BIM is, but you can see so many definitions online. I'm not going in detail of that anymore. Now we already have got some gist of how civil engineers can be connected in different locations of this project. So in the environmental side and all these, but let's see some real application of that too. So this is a real BIM model of a building where architecture drawings, structural drawings, and mechanical, electrical, and plumbing, all of them are overlapped in 3 dimensions. So if there is any conflict, that can be seen as well. Now from that, the data is transported to software like SAP 2000 and ETABS and other analysis softwares, and some kind of seismic or gravity analysis has been done, whatever was required. And we now know that this RCC column should have this much reinforcement. Automatically, that software, SAP 2000 even, has transported the reinforcement detail back to this model. And now, without drawing a single line, the software has done all this drawing or detailing for us too. So this is a very expensive and hard, laborious work to do by a detailer, which doesn't need a detailer anymore. It has been done now completely 100% automatically. So all that effort that is required to draw this curve and this vertical and this all that is now, all that effort is now shifted towards the BIM experts who will manage all these connectivities between these all experts of mechanical, electrical, plumbing, or architectural structure, all those, and then eventually result in this. So we have the white color, we have the steel mesh in the slab, we have the positive and negative reinforcement in green and magenta in the beam, we have blue colored stirrups in the, all of this automatically been done, not done by a structural engineer directly, but automatically done by BIM software. This is a simulation of a building before in construction, showing the least and most reflective surfaces, so that we can replace a material. It is showing the material you're using and how it is affecting the lighting of the environment. So this is a least reflective surface, and this is relatively most reflective surface, as we see the blacker in color. But then this is the material model, so we can see what material shall we use. A carpet. So this is actually literally using a carpet on the floor. They're just doing a simulation of that there. And once that is done, this is the light analysis, natural lighting analysis of and artificial lighting analysis of a building before construction. This is a computer model. It's showing how natural lighting is being affected. You can see the least reflective surface as well. Not only this, the acoustic analysis can be done automatically as well. And what this software like Revit can do is, there's an icon for installation of a tape or a stereo player. You can put it there in that room and play it there. And while you are moving out on this room in this simulation, you will see sound diminishing because you're farther from it. And if you do this acoustic insulation of that structurally, like with real acoustic design, as we use mathematics in that, if you do it properly, which the softwares can do, you will see a real control of acoustics there too. And so many other kind of simulation before even constructing. We can do all of that. We can correct everything, and we'll purchase a right sustainable. We can give a real sustainable solution by using natural lighting, taking the most advantage of natural lighting from here, perhaps. Now, as I said, the construction drawings are drawn automatically. This is a view of Revit software. You will see this is the pile cap and piles, reinforcement there as well. There's a joint of beam column joint as well, very heavily reinforced. There's the bent bar schedule here as well. None of these lines and details mentioned on them are written or drawn by any person. Everything here is been done completely automatically. Just a person had to, a structural engineer had to do some initial plan work there and someone else did the analysis there. And this, once there was a time of construction, you just give some commands to this Revit software, it will produce all these drawings automatically for us. So all this laborious hard work is not required anymore, but has been shifted towards those BIM experts. They are aware of real things that need to be controlled. Should not be wasting time on drawing these lines and all this stuff anymore. Let me, now once we have talked about BIM, we have seen something that BIM is doing for us. It is important to know a term which is called the maturity of BIM or levels of BIM as well. So if they are numbered in standards, they are numbered from 0, 1, 2, and 3. United Kingdom has already achieved, they targeted 2016 to achieve level 2 of BIM, and they have done it far before 2016 actually. But rest of the world is still struggling to achieve level 2, but they are fixed at level 1 nowadays. So in old times we had level 2, level 0, and even now we have level 0. So if you're writing a contract document and signing it, that is on the paper, that is called level 0 of that. But if that has been done automatically through an IT device or something, and a standard contract is automatically being developed, which actually BIM, open BIM software or source software or building smart softwares they provide as open source, they do them automatically, then there is no need of paper in doing these contracts anymore. So we are shifting towards level 2 perhaps in that time. Level 1 is actually the 3D and 2D models as we use computer-aided drafting for these purposes. If you're using them for drawing, so we are using we are at level 1. So in typical offices, we have CAD drawings being done, 2D and 3D drawings, and then we also do a lot of paperwork as well. So we do a combination of level 0 and level 1. And level 2, that has been achieved by United Kingdom already. It is the collaboration. So they now have automated computerized systems which do that most of this thing automatically. And if an owner decides that I want this to be changed, they have a tablet or a software with them. They may not be literate in structure, designing and all these things, but they have an app for owners who don't have that literacy. They can do their own wish, whatever they want, they can do that change, and all other stakeholders will know what they want, and they will, once that is approved, then maybe a fabricator for a door will know that actually the door should be made up of this type of wood, not that type of wood, because the owner wanted that perhaps, without communicating. So there's an automatic communication and collaboration through that BIM that they have achieved by using these software and hardware tools. What they are seeing in future, what level 3 will bring, is actually now possible with 5G technology in computing. So what everything will be in real time and 100% integrated together as well. It is still a dream being done separately but not integrated yet. It's a big challenge already. So it has standardization as well, so many other things in it, but basically it is like, if let me give you an example like this, that if now a person has drawn a 3D model of the building and they want it to be constructed, so they just press a button and a 3D printer will deploy itself on the site and print the building for them. There's no need for contractor to know that and purchase of the material and that and cranes and all these things. The robot will know, automatically it will know. It has already been achieved in several countries. Finland is one of the pioneers in doing similar things. So what we are seeing is, it is actually going towards digitization. What is level 4? We cannot imagine now. That after 5G, what is 6G is going to bring, we cannot imagine. So time will tell what will be happening there. But then we should actually start achieving at least level 2. Why? Because we already have standards for them. Before we talk about standards, we already have seen a proof of the BIM modeling software, Revit there, but there are several other group of software that are available for doing all different other things that are required in building something. So starting from the top, if you want to plan the execution of the construction, there's a separate software for that. If you have documents, contract documents, and all these contents that need to be managed. There's separate software for that. If you want automatic designing and architectural planning, that you need to do, the generative design softwares are there. They will really create a building that you cannot imagine. The software will imagine a building for you. You just provide that I want this many rooms and this much energy consumption and that and that and that. It will do it everything automatically. Then we can do different types of performance analysis, including the structure analysis as well. We have collaboration software which will connect a contractor's office with the owner and also the structure engineer and also the site engineers. These software will connect all of them to do a very good collaboration. There's separate software, BIM validation and checking software once the construction is being done through the Google Glass or maybe with laser scanning of point cloud data. The point cloud will be automatically checked with the Revit or AutoCAD model, and it will be validated that is it really of that height, everything is of particular size or not. It will do that automatically as well, and they are doing their softwares already exists. We have pre-construction 4D and 5D software, as I told you about. The Navis work is one of the tools for to show the simulation of the construction of anything, and then 5D softwares are the ones which actually simulate the Gantt chart of the project, how once project will progress. If you just move the line on the Gantt chart and assign the resources and see will they work properly or not. So these type of software, we'll talk about these as an important term later on. We have construction BIM software which will simulate a complete construction, as I mentioned, in the 4D type, and facility management tools, as I mentioned earlier as well on that particular figure. Now, we just talked about buildings, but actually BIM is implemented on so many other things. Like in health, for hospital, there is a specific requirement of BIM, so there are separate software for that. For housing, for water projects, for fitness facilities, for infrastructure design, for retail design, for surveying, there is separate BIM. So for infrastructure, landscape, for bridges, we have BRIM as well. One of my students is working on CBIM, which is culverts for roads. So culvert BIM. So now it will take the road data and automatically design a culvert with all these things, with collaboration, everything. Using Excel, it's just modeling everything, doing that in Excel, literally. Now, as I mentioned, for BIM, we have standards. In November 18, 2 of the British standard documents, 1192, were translated into international standards. And now they are 1965-01 and 2. They just talk about some basic concepts of BIM. So if you want to know really more about it, you should read this 30-40 pages document. Delivery phase of assets after construction, how we'll deliver the assets to the owner so that they know what they have, but for so many other reasons. That is the second document. To be released in 2020 is not the fourth one, but the third and the fifth. So fourth and sixth are still, we don't know when we are going to get, because these all standards were British standards. They were relatively easier to translate into international language. They were struggling in conversion of these into international language. So they said we're going to do it in 2020. But the language used in 1192-4 and 1192-6, the language is so much British that they are struggling to even realize that how actually they're going to do that conversion. And they are also required. So they haven't released any date for that, but then they are also required. So this is, if once we have all those 6 of them ready, by that time, we'll have a standard for level 3 of BIM. But now for level 2, they say we have a good set already available to achieve level 2 in BIM, which UK already has achieved. Now, in terms of important terms that we need to know, for BIM, something very commonly is talked about is the dimensions or Ds of BIM. So we know already in CAD we have 2-dimensional drawings, 3-dimensional drawings, and now in terms of BIM, 3D actually not only means just drawings, but we have laser scans and 3D printing as well as a part of it now. And if we add the payments and the scheduling of the project with the passage of time, how things will happen, then if we are doing that as well, then it's 4D, which means that if you have one software that can do 3D modeling of a project, and if we have given a separate software that can do the scheduling, but if they are connected together, then we say we have achieved 4D in our office. But if we have these two software available, but they are not connected together, we haven't achieved 4D. This is what it means. All of these must be connected, then we'll say we have that dimensions of BIM already available. Similarly, 5D is the estimation where we quantity takeoff and all these things. Once we take care of the sustainability, the environmental side of it, energy analysis, we have softwares that can do that. Even we can achieve LEED certification. Like I was so happy to see that this building is LEED certified when I see that. The software can automatically plan a building. We can check that building that will it get a LEED certification or not, or of what level actually. So if a software which is connected to that software, then we say we have achieved 6D through in our office environment. The 7D is for the facility management. We already have talked about it quite a lot. 8D is the decommission, that once the project is passed over its lifetime, we need to decommission it or demolish it. How to do that? Now that is also connected to that. So we are not only designing it at that time, but we are demolishing it sustainably as well. Following this. And very recently, I actually have discovered a 9th D, which hasn't been officially said to be a 9th D, but that is the lean construction. So we need to minimize the waste of material, time, and effort in the construction project while we maintaining or maximizing the value of the project. This is what is called lean construction. And if at some stages it has been achieved in several software, but now we have, if it is connected very well, we'll say the 9th D of the BIM has been also achieved. Still, it's not official. Another very important term, if you will start getting involved in BIM, you will know or hear about is the level of development or detail. To give you a quick idea of that, what you can do is you can provide a symbolic detail which is called LOD 100 level. Now, what do we mean by that? So if an owner is there with you and you want to tell the owner that, look, this part of the building will be RCC and that part will make a steel structure. So if we start giving them such detailed drawings, look at this and look at that, they will totally not understand what we're talking about. But if we just show a symbol that gray color part is RCC and red lines are steel structure, a symbol is enough to clear them what is the difference. So LOD 100 is very important when you're talking to the owner. But if you are talking to a fabricator, you have to give them LOD 400. LOD 100 will do nothing for them. So at a particular office, communicating with some particular person, you have to be taking care of the LOD, what level of detail you should give them. Over detailing will confuse them, less detail will give them nothing. So as we increase the detail or development, we have symbolic and then generic, will not have any size there. So even a small or a larger column will have a same symbol, the same drawing being used. But if we start showing a thinner or a thicker column separately with their size, we have a specific LOD 300. And then if we start showing how they are connected together as well, then we have LOD 350. And then how a fabricator is going to fabricate a part of our structure, then that detail will be LOD 400. And once the construction is being done and we're going to verify it at the site, the document which will have a photograph and even the video clips within it will be called LOD 500. And you can now realize all that is required at different levels, and they're required to validate some parts and have a clear communication and collaboration among the project stakeholders. Now, we already have talked about so many softwares, SAP 2000, ETABS, Trimble has bought now SketchUp software as well, AutoCAD, Revit MEP, Revit Structures, Bentley software, so many other software that work separately in some special things. We have the Energy Plus software to do the energy analysis of the building as well and its own material envelope. The question is how they are actually connected. This answer to that is through IFC or Industry Foundation Class, which was actually built for other type of electronic and equipment, mechanical equipments actually, but now has been brought to the this construction industry. What is that? It's actually, to be simple, it is actually PDF file, you can say, for example. So in your office, if you are adding some information in Microsoft Word software, you're typing it in Microsoft Word, you can do whatever you want, you can write it there. But now once you want your boss to know that, you will send them a converted PDF file. The boss will not be able to change anything in it, but maybe they can use it to do some other work on the basis of your decisions perhaps. So they will take that information from there and connect it to their other activities like that. So the PDF of BIM is actually IFC file. So if someone has done 3D model of Revit and they want Navisworks software to do the construction simulation of how it actually being constructed step by step wise, so they will convert it to IFC or export in IFC. It will be imported there. The Navisworks will never change that IFC file. It will read and simulate it. But if there is a clash there, it will detect it and then it will correct it and it will create a separate clash clearance IFC file which will be imported to Revit and clash will be removed there. So this is how IFC works. It's simply a file with this extension of .ifc and it is used to connect all these together. You can write Excel softwares and other software to create standard IFC files. They should be written in a special language. This is called semantics in computer sciences, but let's not go in any detail of that. Beside IFC, there are so many other formats. Like in Microsoft Excel, there's another format that is used is Kubi one, which is construction of building information exchange, and it is in Microsoft Excel, and that can be converted into IFC, and IFC can be converted into this as well, and into so many other softwares too. Like Autodesk have now a Green Building Studio, which is online tool for energy analysis of the building. That need green building XML files. They can be converted to IFC, and IFC can be converted to this as well, including PDF too. But then again, the standard remains to be IFC. It has to be through IFC. I already have talked about level of detail. I'm not going to talk about more on this slide too. But then just to see in detail what are the other things which will be in level 3. This is a very famous figure. When you search BIM in BIM levels in Google, you will see so many places. This is what is the standard that they want to achieve. We know that in level 3 we have some ISO standards that have already arrived. We are still waiting for more, so it is in front of the red line. But the UK has achieved level 2, so this red line was actually for the United Kingdom, perhaps. Last thing I want to show is the Sustainable Developmental Goals arranged in pyramid form. And the lower part of the pyramid here is about people. The upper one is the ecological part. The upper one to that is spiritual. What I want to clear here is that imagine again whatever I have said today. We are actually creating new jobs by introducing a new industry of BIM. Our engineers are getting certified with some different thing. We are saving water. We are designing, and our buildings are just not concrete or steel buildings. And the importance of the life in sea or above the ground, the trees and all these things have been taken care of through this collaborative system. So we're doing that as well. We are not just saying that is a detailer and that person is a very big owner and investor and so on. So we are really bringing all of them together and we're listening to everyone. We're giving values to them. So it is literally spiritual as well. So really, BIM is a way to achieve sustainable construction. And this concludes my presentation. This is my email. If you need any details, any documents, any references I mentioned here, you can email me or just for any other topic if you want to talk about. I most welcome your emails. Thank you very much for listening. Thank you. Questions? Anyone? I speak quite loud. Yes, please.
How many projects have been done through BIM?
Oh, so many. Well, because once you ask that, then the counter question is, what level of BIM? So, and then once we answer, okay, it's level 2 BIM, then the question is, was it 4D, 3D, 5D, 6D, 7D? So, I'm glad you asked that. So now we are really talking about how to actually see. So we will say that there will be a project that has been done on BIM, maybe at 3D level, very, very low level, but still talking about collaboration, all these things together with 3D printing and all those things within it. So it will be level 1 3D BIM project, and there will be other types of projects as well. So, but there's so many being done, a lot of work being done, and UK has achieved such level that now if a structural designer has reached to a design stage, they have created a design document, they just email it to a computerized system, which is the building authority of United Kingdom. The computer will read that drawing because of IFC standard, and it will say it is according and abiding the bylaws, and it will just stamp and sign it automatically without the authority knowing that, and they will receive and start constructing the project. This is the level 2 they have achieved. So, and this is the extreme that main project I can say that it has been already done. Very important. Yes, please, sir.
For big projects like communication between the data and the program, for simple and regular projects, is it cost effective?
See, first of all, you're right. We have to see the massivity of it. One of the projects that I'm doing myself is we're constructing a mud house with strength of masonry house, and it is a very small, maybe quarter of this. It's kind of a prototype what we're building, and we're trying to do that using BIM. It's a very small project, but we are doing intensive collaborations and all things. It all looks very ridiculous, but what we are doing in Pakistan, being a developing country, it is very. We don't have bylaws. We have them, but no implementation at all. So this all is a rubbish talk in terms of Pakistan. So just like I'm doing awareness here, I'm doing similar awareness in my country as well. Just so that the people who create bylaws, they come online with that. So answering your question, once, like in UK, now it is mandatory. It is mandatory to follow BIM and level 2 in any type of a project. So once that is a law now, so whatever it's a small project or big project, the company, the consultants, all of them have to have BIM exposure with them. So it is like if you talk about developed countries, that is the situation. But in Pakistan, there's in so many countries, this is a lot of struggle. Even in Canada has done very different things internationally as well. If you go to the Building Smart Canada site, you will see very good documentation there, very cheaply available as well to implement BIM. So there's stepwise details there. In United States, they have modified the BIM through BIM Building Smart as well, and they have Excel sheets. And if you start filling the Excel sheet with your project, you're automatically following BIM. So this is how they made it so easy. If you want those details, just email me and I'll send you all those things too. Sorry for not a direct answer to your question, but then this is the situation. So, yes. Any other question? So a question from me: how many of you now understand what is BIM? Raise your hand, please. Okay. Oh, I'm so happy today. Thank you for me. Thank you again. Thank you, sir. Thank you, sir.
So before we resume our next session, maybe another 5 minutes break.